can we do this in us, in humans? At this point, we started to move right over to working on human subjects. We're all interested in that. We're all getting old. And I'm in the Institute of Ophthalmology at University College London, so we're very eye oriented. And this was actually quite a simple experiment. We asked people, can you see a letter that we present to you in either blue or in red if we degrade the letter? So the letter's becoming more and more fuzzy, and we're saying, what is that red letter? What is it? You've got to identify an A, a B, a C. And it's called a threshold experiment. We work out the level at which you can detect the letter. And if you look at the black dots here for the blue and the black dots here for the red, that's before we gave you red light. We gave you a burst of red light, a single 3-minute burst of red light, and then we brought you back 3 hours later. Now that should, remember, your retina's got more mitochondria than anywhere else in your body. Your photoreceptors, it's a picture of the photoreceptors, and the red dots are the mitochondria. More mitochondria than anywhere else, and it ages rapidly. We brought the people back 3 hours later, we retested them, and the retesting is the red squares. In almost every case, the red squares are lower than the black circles. That means your threshold has come down. That means you can detect something more easily. If we look at the population of people we did that in, there's a 17% improvement in your threshold. That's quite an improvement. And it's slightly stronger for blue than it is for red, but that's because your blue channel in vision is much frailer than your red. You really find as you get older, your ability to see blues is reduced more so than it is for reds. If you're diabetic, if you've got macular degeneration, your blues suffer. But 3 minutes exposure and tested 3 hours later resulted in a very significant improvement. How long can we keep it going? Well, we can keep it going for a while, but basically it's about a week. So we've redid the study a week later. We're running out of subjects here, so there's fewer people. But 1 week later, we don't get that 17%. We get 10% and we get 8%. It's still significant. It's still an improvement. But red light, a burst of red light, does not last forever. Whether you're a fly, a bumblebee, a human, or a mouse, it always lasts roughly 1 week. And that's telling me something about a mechanism. Only 3 minutes. I mean, now we do expose for much longer, but you can be exposed for 2 minutes and you can be exposed for 15 minutes. The results are pretty much the same. So we think this is a switch. It's a switch we're turning on.